energy efficient future. Let us begin the function with a prayer to invoke divine blessings. I request everyone to rise for Tamil Thai. Thank you all. Now, to formally welcome all of us and set the tone for today's inauguration, I invite Dr. M.V. Suresh Kumar, Director Administration, Janssen Institute of Technology, to deliver the welcome address. Sir, the stage is yours.
A very good morning to all our present here, respected dignitaries on the dais, participants from various colleges, our own faculty members, FDP coordinators, and all these staff. So I start the blessings of our chairman here and vice chairman, and also with the support of our principal sir, I stand before you to welcome all of you for this wonderful faculty development program on energy efficiency and sustainability. First and foremost, I take this opportunity to welcome Dr. T.V. Arjunan, Professor, Guru Ghasidas Vishwavidyalaya University, Bilaspur, Chhattisgarh. With your big round of applause. Because he has travelled all the way from Chhattisgarh to Coimbatore to be a part of this enlightening FDP. So welcome you, sir, for this academic development program. I welcome Dr. S. Ilangovan, Vice Principal of Janssen Institute of Technology. He has always been a supporter for all the good what we are doing. We welcome you, sir, to the FDP. A very calm and composed Dr. M. Muthukumaran sir, Professor Head of Mechanical Engineering. He hardly shows any emotions, but he performs perfectly. Welcome you, sir. And before I could welcome the two coordinators, I just want to share the incident that happened yesterday at Tiruvallur, Chennai. You might have seen that a train which is carrying gallons of liters of diesel got fire, and we lost around 13 crores, that is 1,300 million rupees worth of fuel yesterday itself. We have all gathered here to talk on energy efficiency and sustainability. But to save this fuel, we have to work for months if we are really practicing the sustainability goals. And to save that fuel which caught fire yesterday, we would have spent months to save those fuels, but it went off just 6 hours, everything went on fire. So why this is happening? Sustainability also have connectivity with carelessness, because we take things for granted. Whatever the duty that we do, we must do it with utmost care. Okay, so careless and less care has created such an accident. If the staff at the lower level, if they could have checked all the safety measures properly before dispatching those fuels, this big incident would not have happened. So we must always be like, never be careless or never take any less care on even small things. So two apt gentlemen who never take care for granted. One is Dr. M. Madhishwaran and another one is Dr. L. Anuj Kumar. We all know, Janssen faculty members, they all know how tough they are when any task is provided for them. They work tirelessly and they were always up on us to perform and get the desired result. So very apt persons who are coordinating this faculty development program. So with your big round of applause, I welcome these two nice gentlemen and also thank you for providing me opportunity to deliver the welcome address. Thank you, sir. And whatever we do at Janssen's, this is an auspicious occasion for us also, because this is the start of 17th year. Our academics are getting started, 17th year. So we are very happy and we are also welcoming our students back to the academic foray. So this is also an auspicious occasion for JIT also. I also welcome the faculty members from the other institutions. It is very tough these days to get on duties from self-financing engineering college or be it a government engineering college. It's very tough because the faculty members' responsibility list has expanded so much that right from a fees, so till submitting the file and taking the responsibility for result and internships, placements and also alumni. Look at the role. Everything that you people are taking care. And I request everyone to give a big round of applause for those faculty members who have taken pain to visit Janssen today. So I'm very happy to welcome you all for this FTP and my fellow team members, my faculty colleagues from Janssen Institute of Technology. No words are enough to thank for supporting us in all the ways. And here also I thank you again and welcome you again for this FTP program. Yeah, okay. Should be very happy. Okay. And I also read up my heartfelt welcome to the IAC President, Dr. Meenakshi ma'am. And she and along with our team has put 4-star rating. She has achieved, our team has achieved 4-star rating in Institution Innovation Council for 3 times in a row, which is no less effort. Even the IITs of India are on par in the scaling. Okay, so we are also on par with those institutions. So consecutively for 3 years, our IAC could achieve such a feat. So I welcome you, ma'am, for this program, and all the support staff who are always the backbone of all the programs. I welcome one and all, and I hope your commitment will never be careless and you won't do any less care for the forthcoming 6 or 7 days of 6 days of FDP. So I thank you once again for providing me this opportunity and welcome you all and have a wonderful stay at Janssen's. Thank you.
Thank you, sir, for your heartfelt welcome and for highlighting the importance of sustainability in every aspect of life. It's our privilege today to host a distinguished personality as the chief guest of this program. To introduce him to the esteemed gathering, I now invite Dr. S. Ilangovan, Vice Principal, Janssen's Institute of Technology, to unveil the profile of the chief guest. Sir, please.
Good morning, one and all present here. I'd like to take the blessings of the Almighty and all the management people and principals, sir, and all for this auspicious occasion. So this is the program, one important program, Atal FDP, in a physical way. So normally a lot of Atal FDPs we are attending starting from the COVID season. So this kind of physical FDPs, I always believe that a lot of insights will be there. When it is online, we will be parallelly doing, managing things. So we may not concentrate completely on the inputs. A lot of valuable inputs are getting delivered, but how we are, how much of input we are taking, that is very important. So I'd like to congratulate both Dr. Madheshwaran and Anuj Kumar for applied and got the funding from Atal. And as far as this particular FDP is concerned, I'd like to join with Dr. Suresh Kumar in welcoming one and all. And I would like to thank all the external participants and the head of institutions of the other colleges also. By means giving 6 days on duty. It is one side tough for the faculty members coming out of the college, and I know that parallelly you will get then and there your calls, but I hope being a physical FDP, you will get a more insight on it. And today we have got an chief guest for this day. So I have personally connected with Dr. Arjunan sir when we were worked earlier. So I'm really happy to unveil his profile. Professor Dr. Arjunan is a professor in the Department of Mechanical Engineering, Guru Kasidas Vishwavidyalaya, Bilaspur. His active research areas include solar thermal applications, heat transfer, desalination, fluid mechanics, energy systems, etc. He has a vast experience in teaching and research. For about teaching and research, again I'm underlining this. Before completing PhD, we will be doing research. After completion of PhD, we are more into academics or kind of getting funding, all those things are. But the real research will happen only for their students. Students will do the research, and the guide will add their name in their publications and other things. But it is not the case in Dr. Arjunan's profile. He is really doing research till now, and he is really guiding their students also. So based on his personal connect, I am saying all these things. Yeah. So about 23 years, during which he has developed many innovative solar thermal systems and supervised many research projects of undergraduate, postgraduate and doctoral thesis. He has executed many sponsored projects, workshops, seminars, research projects worth more than 3 crores from various funding agencies such as DST, AICTE, CSIR, ISTE and MHRD. He has carried out many collaborative research projects with the researchers working in India and abroad. To his credit, he has 5 patents, of which 2 international applications, and authored more than 120 research papers in the peer-reviewed international journals and conferences. He has contributed 4 book chapters in the field of solar energy systems and published by Springer Nature. In addition, he is serving as a reviewer in various highly reputed international journals. He is an active life member in several professional bodies such as ISTE, SAE, Bioenergy Forum and Solar Energy Society of India. In recognition of his research work, he has awarded with KF Ankia Memorial Award from Institution of Engineers, India, and received certificate of recognition from ZF Wind Power Coimbatore for contributing in bearing information system proof concept development. He is a vibrant speaker and delivered many keynote addresses in the international and national level. And he has delivered various seminars organized by reputed institutions in and around India. So we have taken a lot of time to summarize his profile. It went on pages. So such a wonderful person is here. It is not only the technical aspect you are going to get today. So please interact with him during the breaks so that you will get a lot of inputs about how to apply for a funding, how to get it, how to do a real research for the lifetime. Thank you.
Thank you, sir, for the gracious introduction of our chief guest. And now, the moment we have been waiting for, the official inauguration of the Faculty Development Program. We are honored to have with us Dr. T.V. Arjunan, Professor at Guru Ghazidas Vishwavidyalaya, a central university in Bilaspur, Chhattisgarh, who has graciously agreed to inaugurate this program and deliver the presidential address. Sir, we invite you to kindly inaugurate the program and share your vision on the topic.
Very good morning to Randa, respected Director of Admin and Vice Principal Sir, Head of the Department and the coordinators, Mahesh and Anush Kumar, and the faculty members of this institute and the participants from various institutes. So very good morning to Randa. So really I am very happy to be see the offline program. Normally, nowadays they are motivating online, but now they return back to enforcing that they have to conduct offline programs. So the ACTE, wherever the funding agency they are providing fund. Nowadays you see that on everywhere they are talking about energy efficient and sustainability. Even today's our workshop title also the same thing. Anyway, technical talk, we have the next session. So what is the root cause of this talk? So all the government and you can find that not only India, all the world, many countries, they are working on this energy. Do you know what is the reason behind that? Everybody is talking about maybe once upon a time when we were working on the solar. So we are thinking that depletion of fossil fuels, so fuels will not, after 50 days we will not get the fuel, so that we have to find the alternate solution, so that we have to work for the wind, solar, biomass, many activities. But actually that is not true. That is there one side, but the major problem is the environment, global warming. That is a major reason behind this talk. See, even 1850 till 1850, if you see the carbon dioxide emission at the world level is constant and is a very sustainability. It's a balance in the world. So once the industry era starts, after 1850, then when we are starting with the burning the fossil fuels like coal, gas, other fossil fuels, then it started all the, because we need the energy, suppose that is the industrial era, so that we need lot of energy. For that we have burned many fuels, so that all the fuel is emitted the carbon dioxide to the environment. So because of that, what happened at present, so our environment have 52% of carbon dioxide more than what we have, it is supposed to be sustainable. So this is the main reason. So what will happen if it is keep on increasing carbon dioxide? So it reflects the change in temperature. That is the increasing the temperature of the earth. So if you see our body temperature, normally 97 degree Fahrenheit. Suppose if you increase 2 degree, suppose if you go and check with the doctor, if you get 100 degree, then they say you got the fever. So if the fever is, we are in the unbalanced. We will not work properly. We are not in a position to do what are activities. The same, because environment also, it is a physical phenomenon. Environment is a physical one. So if you increase the temperature, then that is also will you get imbalanced. So because of those kind of activities, nowadays we are getting lot of national disaster. You can find recently Kerala they got it, and every time you find ice is melting, nearly 40% ice is going to melt. So every year you can find in Bangladesh certain places are shrinking. Every year the people are moving. Similarly, the Indonesia, there is a capital of Indonesia also. That is one of the fast sinking city in the world because of this. So these kind of lot of activities you can find many places in the forest fire. So because now people they have identified this is going to be a big issue for the environment. Yes, not only in the particular country, to whole the world. That's why in the 2015, all the countries they have conducted a meeting. They have it's called Paris meeting, Paris conference. So. Today, the topic given to me is solar thermal sector for the industrial process. So in this, we are going to see about how normally solar energy. If anybody talks about solar energy, then immediately in our mind will come solar panel, PV. So this is knowledge that people are having more. So whenever you talk about the solar energy, immediately we know the solar power panel. So we are also having in our home, in our industry. So this is the knowledge. But actually there is another part apart from the electrical energy. So solar PV is nothing but the solar energy is converted into electrical energy. Then it directly send it to the supply. So we are getting the power. Okay, through the inverter, because now we are using the solar PV converted DC only. So we are using AC, so that through the inverter we are converting that into AC that we are using in the home. This is what maximum people are understanding about the solar energy. But apart from that, there is one more conversion is called heat. That solar energy can be converted into heat. That's the heat energy also. It is a very simple technology. Suppose if you are keeping any vessel or something in the top floor, in the terrace, then after some time in cold sea there will be a heat now. So then it seems there is a sun energy is having the some energy. That's why it's getting any water or vessel is getting heated. So that is the concept behind this. So there is another next. Yeah.
Second session of this Atal FDP on energy efficiency and sustainable practice, advancing green technology with solar thermal systems. So I am very happy to introduce our chief guest, our resource person of today's the session, Dr. G. Saravanelango, Professor in the Department of Electrical and Electronics Engineering, National Institute of Technology, Trichy. We welcome you, sir, for handling this session. Let me give you a small introduction about yourself. And he completed his BE in Electrical and Electronics Engineering, ME in Power Electronics and Drives, PhD in Fax Controllers, and is a postdoctorate fellow at the Department of Electrical and Computer Engineering, North Carolina State University. He has more than 20 years of teaching experience, and to his credit has published more than 100 plus papers in reputed journals in Web of Science. He is an excellent researcher in the field of photovoltaics and power electronic converters, and he has received an amount of more than 300 lakhs towards research from DST, MNRE and many other funding agencies. He has also received Young Scientist Award, Young Faculty Research Fellowship Award, and also Bhaskara Advanced Solar Energy Fellowship Award from DST. We are pleased to invite you, sir, to deliver the session on renewable energy and significance of solar PV system. Probably this will be an enhancing session for us in green technology. Session is yours, sir. Thank you.
Okay, so a very good afternoon to all. Okay, so basically I am from electrical engineer. I don't know how much all you are here of electrical. Okay, so maybe there is a mixture of electrical, I don't know, mechanical, right, electronics and all those things. Anyway, let us see that now whether I am able to make you interesting or maybe something which you may learn. We'll see it as it goes. So basically, if I get inside, it looks very much in electrical. Okay, but I try to make it in such a way that everyone actually understands what I want to say. Okay, though it is an electrical, let us find out the way out, to understand actually, what actually I try to convey. Or maybe it will be of a different story. Okay.
Good morning, everyone. On behalf of Jansen's Institute of Technology and Department of Mechanical Engineering, I am happy to welcome our distinguished speaker, Dr. Raghuram Arjunan, and the participants for the day 2 of the ACT Atal FDP on energy efficiency and sustainable practices, advancing green technologies with solar thermal systems. I am happy to unveil the profile of our eminent resource person, Dr. Raghuram Arjunan. Dr. Raghuram Arjunan, the founder and managing director of CARE Renewables Private Limited and CARE Academy. He received his Bachelor of Engineering in Electrical and Electronics Engineering from Anna University in 2007. He completed his Masters of Engineering in Energy Engineering from PSD College of Technology in 2010. He received his doctorate in Solar PV Systems from PSD College of Technology in 2022. And he also undergone advanced training in photovoltaic material and device modeling in Delft University, Netherlands in 2024. Dr. Raghuram began his career as a project engineer at Aspiration Energy, where he gained hands-on experience in solar energy projects, laying the foundation for his future endeavors in this renewable energy sector. Because of his passion towards solar photovoltaics, he established CARE Renewables in 2012. Dr. Raghuram has been instrumental in consulting on over 100 megawatts of solar PV projects across India. He has also spearheaded the design and development of several centers of excellence in solar photovoltaic systems at esteemed institutions including PSD College of Technology, Ramakrishna Advanced Training Institute, BMS College of Engineering and others. His leadership has driven the training of over 10,000 individual technicians, students, engineers and professionals in the field of solar energy. Dr. Raghuram's expertise has been sought by various government bodies including MSME, MNRE, NPC, etc. Also, Dr. Raghuram serves as the President of Sustainable and Energy Practices Association, SEPA. Then we are happy to have you here, sir, to deliver the session on technical challenges and business opportunities in the restructured solar energy. Happy, sir.
Thank you.
The stage is yours.
வெரி குட் மார்னிங். எல்லாரும் தமிழ் கன்வீனியன்ட் இல்லைங்க. நிறைய பேர் நிறைய சொல்லியிருப்பாங்க மேடம். இட்ஸ் வெரி சிம்பிள் தட் ஃப்ரம் 2010லேருந்து ஆல்மோஸ்ட் ஒரு 15 இயர்ஸாக வந்து சோலரில் ஸ்ட்ரகிள் பண்ணிகிட்ருக்கேன். இன்னும் ஸ்ட்ரகிள் பண்ணிகிட்ருக்கேன். ஸோ Madhesh is my senior. So when they invited, like definitely நம்ம வந்து கண்டிப்பாக வந்து அட்லீஸ்ட் நம்ம கிட்ட லேர்ன் பண்ண நாலேஜை வந்து கண்டிப்பாக ஷேர் பண்ணுங்கிற ஒரு இதுதான். பட் இந்த மாதிரி ஒரு ஃபேக்கல்டி டெவலப்மெண்ட் ப்ரோக்ராம் வந்து ரிசர்ச்காக இப்போ வந்து நீங்கள் நிறைய ப்ரோக்ராம்
he is able to attain a H index of 17 and good citation count of more than 1200. So we can understand how good researcher he is, and he published about 6 patents, out of which 5 patents are granted. He is an ardent researcher that led to the development of his own company, Shiny Unicorn Solar Technologies Private Limited, and he established the company in 2024. His research work was recognized through various grants. He has obtained about 35 lakhs of grants and is the winner of Onion Grant Challenge, Yukti Innovation Challenge, TAN Seed 6.0 and Social Innovation at IIT Kanpur. So more he will be discussing about that in detail. And we welcome you, sir, to deliver this session on analytical modeling of solar thermal systems. Sir, this session is yours. Thank you.
First of all, I thank Department of Mechanical Engineering to give this opportunity. While we submitting this proposal, HOD are insisting us, so we will take one session, especially in solar thermal systems. So based on his recommendation, so I am handling one of the session, how to develop the analytical model. So how I enter into the analytical model is a different way. So when I met a guide during the analyst evaluation, so I met my guide only through analyst evaluation. After the evaluation, during the meantime, I discussed with my guide what we have to do for the research. During that time, he insisted to search for some journal papers. So I collect the journal papers and send it to him. So while we doing the discussion, initially my objective is only do simulations. How to do simulations with the help of already developed codes, especially in CFD, computational fluid dynamics. But when we go through the papers, we understand that these codes, what we have in already existing software, these things are not for specific problem solving. It is generalized. So if you have a unique problem, you have to develop your own analytical model. So that is the requirement. So for the purpose, so he guided me. So a good research supervisor not help for throughout your research. He only insisted what to be do, what cannot, what should not do. That's the thing. He will not do each and every equation and he will solve, he will conduct the research. No. He only insists which path you have to select, which path we should not go. So that is the right thing. So in the first day itself, I get the correct guidance. So which paper I have to take as a base paper, then how to do the analytical model. So that is the thing. So with the help of that first day, I met him and he insisted to make the analytical model. So it created more interest to me. So then I start to do the analytical models, especially for solar thermal systems. So why I am particularly interested in this area means, you know, in mechanical engineering, one core subjects we have thermodynamics. Thermodynamics is the basic subject for how heat energy is converted to useful work. So I particularly interested in that domain. So I do my BE project also in hybrid vehicles. Then ME also we did it in energy engineering. We do heat exchanger design as a final project. Then, so when I come to the teaching career, I only teach thermal based subjects only. I will not go for other subjects. Only thermodynamics, thermal engineering, heat transfer, power plant engineering. Then I'm also interested in economics. So some subjects related to engineering economics also I teach to my students. So due to that experience, how this core knowledge to be converted as a product. So for the purpose, I move on to the development of solar heaters. So once I completed the PhD in the institute, they ask, what do you want to do? Whether you come for the NAC criteria coordinator or you may take the Institution Innovation Council. So I take the choice of Institution Innovation Council. So that makes a tremendous change how the research output can be converted as a product and to be marketed, or it is to be commercialized. So for the purpose, then we, with the help of the last 2-year training programs, attended various incubators, AICT, that makes me to launch my product in the market. Still we are learning. We are in break-even level only. We are not getting any profit so far. At present, what we are doing means, at present our product is at TR level 8. So we are developing the product, giving to the customer. Based on the customer feedback, we are modifying all these things. But all these things, where we start, all these things come from this thing. So if you have strong knowledge in your fundamentals, definitely you may be able to develop the product at research level and also we will go for the commercialization. So the agenda for today's session is, so Arjun sir already discussed these things, the need for solar thermal energy, then solar heating for industrial processing. Then what are the challenges? Even though this is a good idea, why it is not commercially viable? Then if you want to develop such system, what is the role of mathematical model? So that is the thing. Then I will have 3 case studies in my presentation. How to develop the solar air heaters, how to develop the analytical model. Then water heaters, how to develop it. Then for desalination system, how to do it. So that is the thing. So we have to discuss it. So what is the need of solar energy? So as per the International Energy Agency, the total energy requirement in the world is nearly about 360 exajoules. Exajoules means 10 power 18. Okay. So exajoules, if you convert it to joules, means is 10 power 18. So that is the energy requirement and the total energy requirement in the world. So among that, 32% is taken care for industries, 31% for transport, 24% for residential, 13% is for others. So if you go to this pie chart, among that, the 32% is consumed by the industry. So among that, how much exajoules? 360 exajoules. So look at here this separation again. Among this 32%, 74% of the industries finally they use the energy in the form of heat. Only 26% is go in the form of electricity. So this data give more interest to me. Definitely there is a chance to integrate the solar thermal for the industrial process. So look at this data. Only 74%, the end use will be, even though we are supplying electricity, 74% the final form of energy to be used in the industries are heat only. Only 26 is electricity. Okay, what is the present contribution among the 74%? So 45% is we extract it from coal, 30% is natural gas, 15% is oil, 9% is renewable, including hydroelectric power. That is also included in this 9%. Then 1% from others, especially nuclear and other things. So this is the contribution. So among the 74, this is the contribution by non-renewable and renewable energy. So if you take this 74%, that is equal to 85 exajoules. So among that, how the energy is again splitted here means 30% go for low temperature applications. So only up to 150 degrees Celsius, that is a low temperature. 22% is medium temperature applications, and 48% is high temperature applications. High temperature means 400 degrees Celsius, medium is 150 to 400, low temperature is up to 150. So this is the contribution. So from this database we know that up to 30%, this 52% we may be able to concentrate with the help of the locally available technology. If you go for this 48%, it is very severe. We have to invest more, we have to develop a lot of technologies to obtain this 14%. So at present, in our presentation, we only move on to this, how to use our solar, especially to satisfy this 52% of energy requirement in the industries. That is the requirement. So that is the one side. On the another side, we know that international solar energy, their ultimate objective is we have to go for net zero emissions. So we have to reduce the pollution by zero, okay, within the year of 2050. Okay. So what is the current emission rate means? It is equal to 30,000 metric ton of carbon equivalent. So that is that happens at before 2020. At present they are slowly, gradually reducing this emission level. Our ultimate objective is we move on to go for net zero emissions. So that is the target for all the countries. So when we teach to the students, we started our session like this. All the developing and developed countries bothering about 3 E's. What is that? Energy, economy and environment. They want to produce the energy and consume the energy without spoiling the environment and without affecting their economy. So if you do these 3 E's in an effective way, then that countries are known as developed countries. So that is the thing, all the governments are focusing on these 3 E's, energy, economy and environment. So based on the environmental policy, so the International Solar Energy Society described that we have to go for net zero emissions. So if we go for 100% renewable in 2050, so what is the contribution of each renewable energy? So look at that, if you go for 100% renewable, 69% will be comes under the category of solar, 18% by wind, biomass will be 6, hydro by 3, geothermal by 2%. So that's why, so our focus is on this sector, solar. Solar have a definite future. So it may be PV thermal, solar thermal or solar photovoltaics. Definitely if you attain this one, the researchers, economists, every people, environmental engineers accepting that this one, 69% come from solar. So why solar? So these are all the data. So it's a reliable source, no transportation is required, no taxation. This is another important thing, geopolitical crisis. It will not affect geopolitical crisis. So due to these advantages, this is the very important one. So you may use solar energy by solar collector, directly converting thermal energy. So sun produces the radiation. So the radiation heat is to be converted as a hot water or hot air for industrial applications. Or using PV panel. So if you use PV panel, the photovoltaics, so we may directly convert it as a electrical energy we may use. So that is the thing. So this is check the contribution. At present, 23.7% of renewable energy share is there in global electricity consumption. The global entire sectors, not only Indian industries, the total energy supplied by renewable energy in all the sectors in the world is the total contribution is 23.7%. Okay. Look at here in industrial sector. What if you go for that 85 exajoules, 9% is only come from renewable energy. 9%. Only 9% comes from renewable energy. The next one is, if you go for industrial process heating, what is the contribution of the solar?
So welcome back to the second session of today's Atal FDP. I am very happy to welcome our resource person and introduce our resource person, Dr. K.K. Ajit Kumar, founder and CEO of Matrix, Material Research and Innovation Centric Solutions. A small profile about Dr. K.K. Ajit Kumar. Dr. K.K. Ajit Kumar completed his ME in Engineering Design from GCT and PhD from School of Mechanical Science, IIT Bhubaneswar. He served as PDF at IIT Kharagpur. In 2014, he was honored with Professor Brahm Prakash Best PhD Thesis Award by Indian Institute of Metal, Trivandrum Chapter. So far, he guided 3 research scholars and currently supervising 2 scholars at NIT Trichy. He has strong background in alloy development and material characterization, and he has 54 peer-reviewed publications and reviewer of 10 journals. Driven by passion for metallurgy and innovation, he found Matrix. So sir, we welcome you to share your expertise on research and innovation in magnesium alloy and composite. Sir, the stage is yours. Thank you.
Thank you very much, ma'am. My sincere thanks to Johnson's Institute of Technology and the coordinator of the AACT training and planning, Atal the FDP program, Dr. L. Anuj Kumar, and co-coordinator Dr. M. Maheshwaran. Thank you very much, and all the faculty members and people who is attending this FDP program. ஸோ மத்தியானம் ஒரு அழகாக சாப்பிட்டுட்டு உட்காந்துருக்கோம். இது நான் அப்படியே டெக்னிக்கல் செஷனாக கொண்டு ஏன்னா டாபிக் பார்த்தீங்களா, ரிசர்ச் அண்ட் இனோவேஷன் ஆஃப் மெக்னீஷியம் அலாய்ஸ் அண்ட் காம்போசிட். யாராவது மெக்னீஷியத்தை பற்றி கேள்விப்பட்டிருக்கீங்களா? யாராவது கேள்விப்பட்டீங்களா? கைத்துக்கோங்க. கேள்விப்பட்டது இல்லைல்ல? ஓகே, ஒரு 4-5 பேர் தான் கேள்விப்பட்டிருக்கோம். ஸோ ஜெனரலாக மெக்னீஷியம் மெடிக்கலில் நம்ம யூஸ் பண்ணுற வேடா இருக்கும். உங்களுக்கு மெக்னீஷியம் குறைபாடு இருக்குது, நீங்கள் கொஞ்சம் கீரை சாப்பிடுங்கன்னு சொல்லுவாங்க. ஓகேவா? ஆனால் இப்படி ஒரு மெட்டல் இருக்குது. இந்த மெட்டலோட பேக்ரவுண்ட் என்ன, இதை பற்றி டீப் மெட்டலர்ஜி நான் இப்போ கிளாஸில் மீன்ஸ் எப்படி போய் ஆகணும்னா 10 நிமிஷத்தில் எல்லோரும் தூக்கிடலாம், 4 சேர்ந்து. ஸோ டிஸ்கஷனாகவே நம்ம இந்த FDPயை கொண்டு போகலாம். அப்போ தான் கொஞ்சமாச்சும் என்டர்டெயின் ஆகிடும். ஸோ அதுக்கு முன்னாடி ஆல்ரெடி இன்ட்ரோடக்ஷன் கொடுத்துருந்தாங்க. ஸோ இன்ட்ரோடக்ஷன் வேணும். ஸோ என்னோட கம்பெனி பற்றிய பேசிக் சொல்கிறேன். பேசிக்காக அந்த கம்பெனி மேட்ரிக்ஸ்னால் மெட்டீரியல் ரிசர்ச் அண்ட் இனோவேஷன் சென்ட்ரிக் சொல்யூஷனோட அந்த இனிஷியல் லெட்டர்ஸை ப்ளஸ் பண்ணி அந்த மேட்ரிக்ஸுங்கிற வேர்டை க்ரியேட் பண்ணியிருக்கேன். ஸோ ஒரு லோகோ இருக்குது பார்த்தீங்களா, இதான் எங்களோட லோகோ. இந்த லோகோக்கும் மெட்டீரியல்ஸ்க்கும் ஏதாவது கனெக்ஷன் இருக்குதுன்னு தோணுதா? என்ன கனெக்ஷன் இருக்கு? ஸ்ட்ராங், யா, கரெக்ட். வேற ஏதாவது? ஸ்ட்ராங், ஹார்ட், ஃப்ளெக்சிபிள் எல்லாம் சேர்ந்தே இருக்காது. ஹார்டாக இருந்தால் பிரிட்டிலாக இருக்கும், அப்படிதானே? எது எப்போ ஹார்டாக இருக்கும், கிரானைட் ஹார்டாக இருக்கும், பிரிட்டிலாக இருக்கும். பெண்ட் பண்ண முடியுது, ஸ்ட்ராங்காக இருக்காது. ஸோ மேக்ஸிமம் இது ஒரு கம்பைன்டு காம்போசிட். எல்லா ப்ராப்பர்ட்டியும் கம்பைண்டாக இருக்கிறது மாதிரியான ஹார்ன் வச்சுருக்கோம். இதோட கொம்பில் எல்லா ப்ராப்பர்ட்டியும் இருக்குது. ஸோ அந்த ப்ராப்பர்ட்டி டெய்லரிங், ப்ராப்பர்ட்டியை கஸ்டமைஸ் பண்ணுற எஃபெக்டை நேச்சுரே இதோட கொம்புக்கு கொடுத்துருக்கு. ஸோ அதனால இதோட ஹானை மட்டும் எடுக்கிறதா நினச்சி லோகோ ரெடி பண்ணேன். பட் வெறும் ஹான் என்னன்னு தெரியாது, அதனால காண்டாமிருகமும் சேர்ந்துருக்கு. ஓகே, ஸோ நாங்கள் மெயினாக என்ன பண்ணுறோம்னா மெட்டீரியல் சப்ளை பண்ணுறோம், கஸ்டமைஸ்டு மெட்டல் ப்ராசஸிங். ஸோ நீங்கள் இல்லைன்னா ஒரு கம்பெனி ஒரு மெட்டலை யோசிக்கிறாங்கன்னு வச்சுக்கோங்க. ஃபார் எக்ஸாம்பிள் அலுமினியம், அதில் கோல்டு, சில்வர், பிளாட்டினம் இதெல்லாம் போட்டு மிக்ஸ் பண்ணி எனக்கு ஒரு அலாய் வேணும்னு கேட்டால் நாங்கள் அவங்களுக்கு அந்த அலாயை பண்ணி கொடுக்குறோம். இதுதான் எங்களோட மேட்ரிக்ஸோட சர்வீசஸ். ஸோ மெயின்லி அதர் தேன் ப்ராசஸிங் we are doing material characterization, secondary processing, machinability experiment, castability experiment, heat treatment experiment, like all the materials based experiment எல்லாமே இதில் பண்ணுறோம். ஜஸ்ட் ஒரு சம் ஸ்லைட்ஸ் வந்து நாங்கள் என்ன பண்ணிட்டு இருக்கோங்கிறத பற்றி பேஸ் இருக்கு. அதுக்கப்புறம் நாம மெக்னீஷியம் ரிசர்ச்சுக்கு போகலாம். ஸோ மெயினாக நாங்கள் 3 விஷயம் பண்ணுறோம். இங்கே என்னன்னா சேல், சர்வீஸ் அண்ட் ரிசர்ச் அண்ட் இன்னோவேஷன். இந்த கம்பெனி ஸ்டார்ட் பண்ணுறதுக்கு எனக்கு எப்படி என்ன வந்துச்சுன்னா, நான் பிஹெச்டி ஆல்மோஸ்ட் 5.5 years to 6 years ஆயிடுச்சு என் பிஹெச்டி கம்ப்ளீட் ஆகிறதுக்கு. ஏன்னா ஒவ்வொரு மெட்டீரியலையும் தேடி அந்த மெட்டீரியலை வாங்குறதுங்கிறது ஒரு பெரிய டாஸ்காக இருந்துச்சு எனக்கு. மட்டும் இல்லாமல் நான் இப்போ ஒரு மெக்னீஷியம் கேட்குறேன்னா ஒரு டீலர் இல்லைன்னா ஒரு என்ன ட்ரேடர் என்ன சொல்லுவாங்கன்னா மினிமம் 100 kg வாங்குங்க சார், அது கீழே தர மாட்டேன்பாங்க. எந்த மெட்டீரியலாக இருந்தாலும் ஒரு மினிமம் குவான்டிட்டி அவங்கள்ட்ட இருந்துச்சு. ஸோ அது நமக்கு ரொம்ப ரிஸ்கியாக இருந்தது. அவ்வளோ மெட்டீரியலை வாங்கி நான் ஒரு பிஹெச்டிக்கு வைக்க வேண்டிய தேவை இருக்காது. இந்த சுச்சுவேஷன் நிறைய பிஹெச்டி பண்ணுறவங்களுக்கு ஒரு ஒரு பெரிய விஷயமா இருக்கு. ஸோ அதுக்காக நாங்கள் என்ன பண்ணுறோம்னா, ஹோல்சேலர்கிட்ட இருந்து 10 or 2 ton 5 ton மெட்டீரியல் நாங்கள் வாங்கி சேவ் பண்ணியிருக்கோம். ரிசர்ச்சர்ஸ் 5 gram கேட்டாலும் நாங்கள் சப்ளை பண்ணுறோம். ஸோ அவங்களுக்கு டைரெக்டாக ரிசர்ச் பண்ணுறதுக்கு மெட்டீரியல் கிடைக்கிறதும் இருக்கும், அவ்வளோ பெரிய குவான்டிட்டி அவங்க வாங்க வேண்டிய தேவையும் இருக்காது. ஸோ சேல்ஸில் என்னன்னு பார்த்தா, இந்த பீரியாடிக் டேபிளில் இருக்கிற ஆல்மோஸ்ட் 48 to 52 மெட்டல்ஸ் பியூர் ஃபார்ம்ல, தட் மீன்ஸ் 99.85 to 99.999 அந்த ஃபார்ம்ல எங்கள்கிட்ட மெட்டீரியல் ரெடியாக அவைலபிளாக இருக்கு. என்னென்னு சொல்றேன், just magnesium, aluminum, copper, iron, indium, manganese to all the transition material, pure metal formula நாங்கள் மீன்ஸ் ரெடிலி அவைலபிள். இந்த மெட்டீரியல் பேரெல்லாம் கேள்விப்பட்டிருப்பீங்கன்னு நினைக்கிறேன். பீரியாடிக் டேபிளோட லாஸ்ட் லைன்ல இருக்கும். These are the rare earth materials. எர்பியம், எட்டர்பியம், லாந்தனம், ஈசோடோமியம், சீரியம். இதோட ரிசர்ச் வந்து லாஸ்ட் 1 decade, அதாவது லாஸ்ட் 10-12 வருஷமா தான் இதோட ரிசர்ச் போயிட்டு இருக்கு. இந்த மெட்டீரியல் வெரி மினிமம் 0.5 or 0.7% நம்ம ஆட் பண்ணாலே ஒரு மெட்டீரியலோட ஸ்ட்ரென்த்தை ஒரு 30 to 40% நம்மளால இன்க்ரீஸ் பண்ண முடியும். ஸோ இதுல these kind of materials nowadays lot of research are going on. இது மட்டும் இல்லாம மெட்டல் பவுடர்ஸ், we are dealing all the metal powders, aluminum, cobalt, copper, magnesium, silicon, selenium, like all the metal powders we are dealing. Same way all nano powders, some of the nano powders is not available in India, we are importing it and selling to people who is doing research. And masterlize na it's a ready made tablet மாதிரி. நாம என்ன பண்றோம்னா, for example magnesium 10% cerium, 10% cerium readily available இருக்கும். ஒரு இண்டஸ்ட்ரி 0.5% சீரியமை ஒரு 5 ton மெல்ட்ல போட வேணும்னு வச்சுக்கோங்க, இந்த சீரியம் மெல்ட் ஆகிறதுக்கு மினிமம் 3 hours ஆகுது ஒரு இதுல. ஆனா அவங்க 3 hours வெயிட் பண்ணாங்கன்னா என்ன, அவங்களோட ப்ரொடக்ஷன் பாதிக்கும். ஸோ அந்த ப்ரொடக்ஷன் பாதிக்காம இருக்கிறதுக்கு என்ன பண்றோம், நாங்க மாஸ்டர் வாரியா சப்ளை பண்றோம். ஸோ அவங்களுக்கு சீரியம் ஆட் பண்ணா அலுமினியம் சீரியம் ஆர் மெக்னீசியம் சீரியம் பீஸ், ஒரு பீஸ் எடுத்து ஒரு 5 ton மெல்ட்ல போட்டு மிக்ஸ் பண்ணா போதும், they will get that 0.5 or 0.7% of cerium instantly. So இதுக்காக தான் மாஸ்டர் லைன் மெயினாக யூஸ் பண்றோம். ஸோ கமர்ஷியல் அலாய் இது ஆக்சுவலி கோயம்புத்தூர் இட்ஸ் a metal poolன்னு சொல்லலாம். மேக்ஸிமம் மெட்டல் பேஸ்ட் ஒர்க் இங்கே போயிட்டு இருக்கு. ஆல் த கமர்ஷியல் அலாய்ஸ் எல்லாருக்கும் நல்லா தெரிஞ்ச அலாய்ஸ் எல்லாம் இங்கே வந்து ரெடிலி அவைலபிளாக இருக்கு. பட் நாம எந்த அலாய்ஸ் ஈவன் இந்தியாவில் இல்லாத அலாய்ஸ் கூட சப்ளை பண்றோம். அப்புறம் சர்வீஸ் பார்த்தோம்னா மெட்டல் காஸ்டிங், பவுடர் மெட்டலர்ஜி, அடிட்டிவ் மேனுஃபேக்சரிங். மெட்டல் காஸ்டிங்னா என்ன, பவுடர் மெட்டலர்ஜினா என்னன்னு நெக்ஸ்ட் ஸ்லைட்ஸ்ல நான் சொல்றேன். ஸோ மெட்டல் காஸ்டிங் இந்த சென்ஸ் நாம என்ன பண்றோம், ஒரு ஃபர்னஸ் இருக்கு, ஃபர்னஸ்ல மெல்ட் பண்றோம். மெல்ட் என்ன எலிமெண்ட் கஸ்டமர்ஸ் கேட்குறாங்களோ அதை பேஸ் பண்ணி மெல்ட் பண்றோம். ஃபார் எக்ஸாம்பிள் அலுமினியம், சிங்க், சிலிக்கான், மல்டி எலிமெண்ட்ஸ் 10 எலிமெண்ட்ஸா இருந்தால் கூட அது மெல்ட் பண்ண முடியும்னா அதை மெல்ட் பண்ணி கஸ்டமர்ஸ்க்கு கொடுத்து அதை கேரக்டரைசேஷன் பண்றோம். அது ஒரு ஃபர்ஸ்ட் செட். இந்த மெக்னீசியம், அலுமினியம், சிங்க், காப்பர், டின் இது மாதிரி எல்லா அலாய்ஸ்லையும் நம்ம ப்ராசஸ் பண்ணிட்டு இருக்கோம். ஸோ தீஸ் ஆர் த மெக்னீசியம் மெல்டிங். ஸோ இங்கே நான் மெக்னீசியம் பற்றி தான் எஃப்டிபி ஆனதுனால இந்த அலாய்ஸ் எல்லாம் ஆல்ரெடி நாங்கள் பண்ணி கஸ்டமர்ஸ் கொடுத்துருக்கோம், எங்கள் ரிசர்ச் ஸ்காலர்ஸுக்கு சப்ளை பண்ணியிருக்கோம். ஸோ பால் மில்லிங் is one part of powder metallurgy. The powder metallurgy now in the hard granite pieces we can convert into nano powders. எவ்வளோ ஹார்ட் மெட்டீரியலாக இருந்தாலும் நானோ பவுடர்ஸாக கன்வெர்ட் பண்ணுறதுக்கான பவுடரிங் ப்ராசஸ் தான் இந்த பால் மில்லிங். பொலிஷன்ங்கிற மெக்கானிசத்தில் இந்த பால் மில்லிங் ஒர்க் ஆகுது. ஸோ ஹைட்ராலிக் ப்ரெஸ் இட்ஸ் அவைலபிள் இன் மேட்ரிக்ஸ். வி கேன் டூ ப்ரெஸ்ஸிங், எக்ஸ்ட்ரூஷன், ஈகேப், பஞ்சிங், ஸ்க்யூஸ் காஸ்டிங், ஃபோர்ஜிங், காயினிங், பிளாண்டிங், இந்த மாதிரி எல்லா ப்ராசஸும் பண்ண முடியும். ஸோ பவுடர் மெட்டலர்ஜி மீன்ஸ் வி கேன் டூ.
Everyone, welcome to the fourth day of the Atal FDP on energy efficiency and sustainable practices, advancing green solutions in solar thermal systems. I am very much honored to welcome our resource person of today's Atal FDP, Dr. Murthy, and I am very much blessed to introduce the resource person to the audience. He completed his Bachelor of Science in Physics from Periyar University with university rank. He then pursued Masters in Material Science and PhD in Tech, and he is a gold medalist. And he received his PhD in Physics from University of Navarra in Spain with the Latin honor cum laude. Dr. Murthy currently serves as Professor and HOD of Nanoscience and Technology at Sri Ramakrishna Engineering College, Coimbatore. He is a proud recipient of DST Inspire Faculty Award. He has authored over 50 scientific publications with H index of total 14 and holds multiple patents, and 2 are granted. He is an ardent researcher and has received a cumulative grant of rupees 1.83 crore from DST, SERB, UGC, etc. He is a reviewer for top international journals and is a passionate speaker at national and international events. His dedication to interdisciplinary innovation inspire the scientific community. Please join me in welcoming Dr. Murthy to deliver the session on leveraging advanced materials and nanotechnology for innovations in renewable energy system. Sir, thank you, and the session is yours.
Thank you very much. I hope that I am very audible. First and foremost, thank you the organizers for considering me as one of the resource person here. And despite several challenges that we have in our academic field, I have requested about the background of all the participants, and I came to know that all of them they are faculty members. So despite your very tight schedules at your office place, you made a decision to attend this event physically, which is very important. Also, I am happy to be here along with my colleagues from Ramakrishna Engineering College, Dr. Gunasekar and Mr. Sendil. They are our very close friends and collaborators, and I am very much excited that I am also be along with them in attending this session. The very first intent of my talk would be something like I know that you are being with for this session for the past 2 days, 3 days or so, and this will be continuing till this Saturday. But my intent is, apart from giving a few intellect on the technical aspects, that I have brought a couple of presentations here. Beyond that, as a academician, as a teacher, and as a researcher, a few important take-home messages that I would like to share at this juncture, which is very important for your professional life. Okay. So, can I be bilingual or should I be only in English? How many of you didn't understand our language Tamil? Tamil understand panikkalam? Yes. So I can be bilingual in between, so that sessions can go more live rather than being monotonous. So, எல்லாருக்கும் ஒரு introductory கொடுத்தாங்க. I am very happy that they have made a very good consolidation. Actually, they have asked for a brief, but I என்ன பண்ணிருந்தேன், அப்ப details CV அனுப்பியிருந்தேன், but they have converted into a word and then they have read it. So usually நம்ம இந்த மாதிரி நிறைய செஷன்ஸ் போயிருப்போம், நிறைய மீட்டிங்ஸ் போயிருப்போம். There is a resource person outside, there is a appreciation, there is an award, நிறைய விஷயம் நம்ம பார்த்துருக்கோம். இதில் எல்லாம் முடிஞ்சு நடக்கிற ஒரு விஷயம் என்னன்னு அப்படின்னா we want to show our happiness, we want to show our encouragements. ஸோ நம்ம என்ன பண்றோம் அப்படின்னா நம்ம கை தட்டுறோம்.
We can proceed. The same thing, the same scenario was happened when I supervised Gunaseran. So he also asked, so is it possible to get that much amount of heat as we have requirement? So I answered the same way. So if you believe me, you continue with this project, continue with this topic, or otherwise it's up to you to decide. So then he will follow me, then he did his work. Okay, so with this few background, then I can start my presentation. So I am going to talk about the heat pumps as a sustainable heating systems. So why the heat pumps are considered to be an energy efficient system means because it's capable of delivering. So only system is capable of delivering the heat output more than when it is electricity consumed for its operation. For example, if we can give 1 kilowatt of heat, the heat pumps will deliver minimum 3 kilowatt of heat output to maximum 4 kilowatt. 3 to 4 times heat output will be amplified. So that is the main advantage of going for a heat pump heating systems. So the main objective of this presentation is to create the awareness on the energy efficient heating systems, especially for drying, water heating, space heating, and also for desalination, and also even for regeneration applications. But we are not attempt so far. A lot of heat is there. So even we can use the heat exchanger to regenerate. But beyond that, if you want to enhance the heat, so heat pumps are another energy efficient device. Even in Tirupur also it's possible to explore. So we are not tried, but we are developing a prototype for the humidification plants. Because the textile humidification applications presently they are using a boiler. So we are planning to explore for the humidification. You can integrate a heat pump, compression heat pump. So that research present I am doing. So this is my outline of the presentation. So first you should give an introduction about this heat pumps. What is the meaning of heat pump? It's like it's a compression refrigeration cycle where an air conditioner is working. So it pumps the heat from one space to the another space. So that is called heat pump. So how it is working means it consumes the electricity as an input source and it is working on a vapor compression cycle, and it pressurizes the refrigerant at the high pressure and high temperature. So this phase change transformation from the vapor to liquid is happening only at the high pressure and high temperature. For that reason we are pressurizing the refrigerant. So the high pressure refrigerant gas, when it is expanded when it is passing through the condenser, it rejects the heat. That heat is recovered and can be utilized for some utilization. Further, then it will be pressurized, gets dropped, then it goes to the evaporator, then the cycle continues. Okay, so this is basic vapor compression cycle. I am not going to explain in detail. So the heat pump systems are energy efficient. So we can say heat pumps are energy efficient. So why means because it's a capability of delivering more heat output. Capability of delivering more heat output than what input it takes for its compression, takes for its operation. That means as I already said, 1 kilowatt is converted into minimum 3 kilowatt. So now this varaikkum na pannirukkude ella heat pumps me pathina at least minimum or 2.5 COP. So if we considering it exclusively for heating means the auxiliaries alla irukku. So if you want to operate the systems, auxiliary systems like pumps, circulation pumps, fans. So if you are considering the electricity consumption of all these accessories, then the COP will be around 2.5. So minimum, if you are considering both heating and cooling, if you are considering, definitely will get more than COP of 4. So that possibility is there. So here the heat pumps definitely it will produce minimum of 3 COPs and average of 3 COP will attain. Okay, for any application for water heating and drying or for space heating. Okay, so here the applications which we can use it for domestic water heating, so domestic bathing applications. or 5 to 10 years back, solar water heating systems are more popular. Now they are switched over to the heat pumps. So even most of the civil engineers and architects, they are promoting the heat pumps. They are promoting heat pumps. Recently, ஒரு 3 பேர் இருக்கக்கூடிய ஒரு ஃபேமிலியில் they installed the heat pump water heaters. அதாவது 10 years back the solar water heating systems are famous. But even நீங்கள் ஒரு 2-3 day ஒரு வருஷத்தில் ஒரு around ஒரு 3 months, 3 to 4 months, ஒரு 90 to 120 days the solar energy is not enough. Especially in Coimbatore climatic conditions, the solar energy is not enough to produce the hot water of 200 to 200 liters. So in that case, we can integrate the solar systems with the heat pump systems. So payback work payback it's possible to produce the hot water even for 100 to 150 days. It's possible to produce the hot water, and the hot water can meet the requirements, domestic requirements. Domestic requirements is 3-4 பேர் family it's more expensive. But if the family is more than or joint family irukanga or 5 பேர் 6 பேர் irukanga, definitely this heat pumps will be more beneficial. So for 400 liters மேல ஒரு daily consumption இருந்துச்சு அப்படினா definitely we can recommend heat pumps. So I will have a comparison of that. I have some slides. Then for space heating, we have done lot of research, extensive research on that for space heating. When I have a chance to have a collaboration with the Kazakh universities. So Kazakh University last 10 years every year 1 month visiting the Kazakhstan for developing heat pumps. So space heating heat pumps different configurations. One initially we start with ambient source, then we integrate the solar. Solar is also in a big problem because in that place we have 4 to 5 hours of sunshine availability is there. So 4 to 5 hours of sunshine availability is not enough to power the solar source. So that integrate with geothermal. So solar geothermal hybrid source, geothermal independent source. So when I work pannirum. So I will explain those things information in later slides. Okay. So this is a need of heat pump. So heat pumps are required for starting by different industries. Specifically food industries applications. Food industries especially for producing the in a form of hot water, in a form of hot air, its requirements are there. In a form of hot air, as we already it's utilized for drying applications. In a form of hot water, it may be utilized for some food processing applications. Even for a paint booth applications, so maximum applications which you can meet out with the help of heat pumps. Now presently in India, the heat pumps are available to produce the hot water or hot air up to 120 degrees centigrade. But the China, they are manufacturing the heat pumps for producing up to 150 degrees centigrade. 150 degrees centigrade. So compression heat pumps are possible to produce up to 150 degrees centigrade, especially for issues. So the refrigerant issues but it's possible to produce up to 150 degrees centigrade using a heat pump, but that technology is not available within TGC. So we are producing presently compressors available compressors used we can produce up to temperature of 75 to 80 degrees centigrade. 80 we need a special compressor. So minimum capacity of 60 kilowatt. 60 kilowatt minimum capacity is required, then we can go for the such type of big capacity heat pumps, or otherwise we can go for the 134A compressors, the 134A system, so which can produce the capable of producing a maximum temperature lift of 75 to 80 degrees centigrade. Beyond 80 is a big question mark, but the companies, very few companies, even IIT Madras, so they have associate companies there. Earlier it was the Aspiration Energy Solutions in Chennai. They are manufacturing a heat pumps up to 120 degrees centigrade for producing the steam, and also the Trigen is another company. They are manufacturing a heat pumps up to 120 degrees centigrade. So the many research and developments are also going in that particular type of heat pump. Okay, so here the temperature requirement is up to 120 can meet out. So we can identify these applications, and we can fit which type of configuration is required, what type of heat pump configuration is possible we can. So these are the types of heat pumps. There is a compression heat pumps. I am going to present, the entire presentation is depending upon the compression heat pumps, which consist of the basic components, is a working and vapor compression cycle, which consists of basic components, compressor, condenser, expansion valve and evaporator. In addition to this, we have some accessories and controls. Accessories like liquid receiver, side glass, suction line accumulator, oil separator, like that we have some accessories we can integrate with the system. And whereas an absorption system is an absorption heat transfer that's available, it's possible to produce more than the very high temperature, but it is only meant for the high capacity systems. So absorption heat transfer is not possible to, thinner capacities is not available. But moreover, if there is a large amount of waste heat is available, then we can go for the absorption systems. So if the heat availability is not there, then it is better to, less heat availability is there, it's better to go for the compression heat pumps. Okay, then absorption heat pump and hybrid type of heat pumps. So these are the different configurations. Out of all these things, commercially available is compression heat pumps. Absorption heat pumps is available but very rare. Okay, when the large amount of heat is available, we can go for it. And absorption hybrid source of heat pumps, it's available but it is in the research level. And there's a reason I am going to talk detail about these compression heat pumps. There is a single stage, two stage, then auto cascade, then temperature range. Based on that, we can low temperature, medium temperature, high temperature, and ultra high temperature heat pumps. Then the ejector cycle, then the refrigerant injection. So these are the different cycle configurations, and this is the then another configuration. It's a classification based on its operation: subcritical cycle, supercritical cycle, or transcritical cycle. So this most of the refrigerants. So the refrigerants are very issued. The refrigerants, so if we can use the refrigerants like R134A, R22, R1234YF, or R290, the propane, butane, refrigerants. So in the refrigerants we can use all these. The critical temperature is around roughly 100 to 110 degrees centigrade. If we can use these refrigerants and the operating temperature limit is within 70 to 80 degrees centigrade, then the cycle is operating within the subcritical cycle. For example, some refrigerants like carbon dioxide. Carbon dioxide refrigerant heat, carbon dioxide heat pumps nowadays are coming up. So even in India, the carbon dioxide is one of the very good refrigerant. But the problem is, if you are using a carbon dioxide, then we need more safety issues. So normal system 40 to 50 bar servo pressure. So the technicians are very afraid. The technicians are not matured enough to handle R134A presently. If we can go for such refrigerants like a carbon dioxide, it is very safety is very important. R32 air conditioners, R14 air conditioners use and the R32, R14 air conditioners they are not possible to maintain. Fire can't able to handle the pressure. So there is a situation if you can go for the carbon dioxide, then it will be still, it is a big issue. But otherwise, if you can go for a carbon dioxide cycle, then it will become that is working on a transcritical cycle. So half of the evaporation is taking place below the critical point, and the condensation is taking place above the critical point. So it's called the transcritical cycle. So our critical temperature is around 30 degrees centigrade. So 30 degrees centigrade carbon dioxide. So it will be a big problem, and also the pressure is around 73 bar. So it will be a big problem. So I think it is better to go for carbon dioxide, even though it is an environment friendly refrigerant. Carbon dioxide is carbon dioxide is a major. If we can utilize that itself as a refrigerant, then it will become an environment friendly. So I think carbon dioxide is a good refrigerant, environment friendly, but it's having some safety issues. It's having some limitations. But it is a carbon dioxide heat pumps are also coming up. Even IIT Madras, then Bangalore, Akshaya Patra, they install this carbon dioxide refrigeration chiller. for their kitchen requirements.
What is the maximum scope?
Carbon dioxide வந்து உங்களுக்கு COP வந்து around 2.5 வரைக்கும் வரும் சார். ஸோ என்ஹான்ஸ் பண்ணலாங்க, பட் இட் கேன் ஆட் தி ஆக்சசரிஸ் எல்லாம் வச்சு பண்ணலாங்க. பட் என்ன ப்ராப்ளம் அப்படின்னா இந்த சேஃப்டி இஷ்யூஸ். ஏன்னா நம்ம ஊர்லேயே பார்த்தீங்கன்னா R32 ஏர் கண்டிஷனர்ஸே நிறைய இடத்துல அவங்களால ஹேண்டில் பண்ண முடியுது, நிறைய டெக்னீஷியன்ஸ் வந்து ஹேண்டில் பண்ண முடியல. ஏன்னா அவங்க அந்த சேஃப்டி இஷ்யூஸ் இருக்குங்க. ஏன்னா உங்களுக்கு அந்த நிறைய இப்போ ஈவன் நீங்கள் வந்து ஒரு டெக்னீஷியன் இஸ் நாட் மெச்சூர்ட் இனஃப் டு யூஸ் தி ப்ராப்பர் ஹோசஸ். நீங்கள் அந்த சிலிண்டர்லேருந்து நீங்கள் கனெக்ட் பண்ணக்கூடிய அந்த ஹோஸே வந்துட்டு 500 PSI ஹோஸ் எடுத்து போட்டுட்டு இருக்காங்க. ஸோ வந்துட்டு சொல்லுவாங்க 500 PSI இஸ் நாட் இனஃப். தேர் வந்து அது நார்மலாக 500 PSI சர்வசாரமாக வந்துடும். உங்களுக்கு ஒரு 800 PSIன்னு நீங்கள் R410Aக்குன்னு தனியாக தான் கேட்டு வாங்கணும். 410A 32 போகும்போது தனியாக கேட்டு தான் வாங்கணும். ஸோ 800 PSI ஹோசஸ் தான் நம்ம யூஸ் பண்ணணும். ஸோ இதெல்லாம் நிறைய சேஃப்டி இஷ்யூஸ் இருக்குது. ஸோ த டெக்னீஷியன்ஸ் ஆர் நாட் ப்ராப்பர்லி மெச்சூர்ட் இனஃப் டு ஹேண்டில் சச் டைப் ஆஃப் ஹை ப்ரெஷர் ரெஃப்ரிஜரன்ட்ஸ். ஸோ அதெல்லாம் இஷ்யூஸ் இருக்குங்க. So there are different cycle configurations. I don't want to take much time.
The AC will get functioning.
Okay. In general, most of them are aware of this. Basic vapor compression cycle is consists of these basic components: compressor, condenser, expansion valve, and evaporator. It's a basic components. In addition to this, here is a compressor. It is used to pressurize this refrigerant. Here condenser, it can able to reject the heat to the surroundings, and from there the high pressure, high temperature gas is converted into liquid in the condenser. Then it goes to the expansion valve where this high pressure liquid is getting expanded to low pressure. Then this low pressure liquid starts evaporating. Then evaporation it absorbs the heat from the surroundings. So it is possible to regenerate the waste heat. இப்போ நிறைய வேஸ்ட் ஹீட் இருக்குன்னா ஈவன் ஒரு ஹீட் எக்ஸ்சேஞ்சரில் போட்டு ஹீட் எக்ஸ்சேஞ்சரில் ரீஜெனரேட் பண்ணலாம். பட் ஹீட் ஜெனரேட்டில் இது பண்ணீங்கன்னா ஒரு 10 kW ஹீட், if it is possible to regenerate using a conventional heat exchanger, then maybe transfer it as a 7 kW or 6 kW or 7 kW. Heat loss ஆகும். Whereas if you can use it, if you are using a heat pump, that 10 kW is enhanced to 13-14 kW. The possibility is there. That is the reason we are going for a heat pump. This cycle is slightly modified. So with the help of introducing a suction line heat exchanger, it is possible to enhance the performance. For that we are introducing a suction line heat exchanger. There we can subcool the refrigerant. And also it is possible to superheat the refrigerant. So these two possibilities are, these two things, subcooling and superheating, are possible if you are integrating a small liquid line suction heat exchanger. So these two things will happen and it will enhance the performance. So it's a liquid line suction heat exchanger. Then we can introducing a subcooler alone. So and here this you can see this difference. So you can see there is 3. It starts from the liquid condition to the 4, whereas here the subcooling 3 to 4 is the subcooling is taking place. So here the subcooling is taking place. From 6 to 1 is the superheating. So subcooling and superheating is taking place. Because of that, COP can be increased significantly. Here we are using the subcooling alone. So here we are introducing a subcooler. இப்போ நிறைய வந்துருச்சுங்க சப்கூலர்லேயே. இப்போ இந்த ஹீட் எக்ஸ்சேஞ்சர் கான்ஃபிகரேஷன் டிசைன்ஸ் நிறைய மாடிஃபை ஆயிடுச்சு. ஸோ இதில் சப்கூலர் எவாப்ரேட்டரில் ஒரு ரோ வந்து கேன் பி யூட்டிலைஸ்ட் as a சப்கூலர். ஏன்னா இஃப் வி கேன் யூஸ் திஸ் எவாப்ரேட்டர் டு அப்சர்வ் த ஹீட் ஃப்ரம் ambient source alone. If that is the case, one row of the evaporator is utilized for subcooler and other 3 rows can be utilized for absorbing the heat from the surroundings. So நிறைய உங்களுக்கு modifications இந்த subcooling நிறைய modifications heat exchanger integration நிறைய வந்துருச்சு. Then we can go for the flash chamber. It's a liquid injection. Liquid injection அப்படின்னு சொன்னீங்கன்னா இந்த nowadays it will become a liquid injections will become a mandate. It's a very essential things. ஏன் liquid injection essential பார்த்தீங்கன்னா some quantity of vapor which is after expansion, some quantity of vapor generated is directly injected to the compressor for cooling. ஏன்னா உங்களுக்கு வந்து கம்ப்ரஸருடைய டெம்பரேச்சர் வந்து ரொம்ப பூஸ்ட் அப் ஆகிடும். கம்ப்ரஸருடைய டெம்பரேச்சர் வந்து if it is crossing more than 80-90 degrees centigrade, the life of the compressor gets reduced. ஏன்னு கேட்டிங்கன்னா உங்களோட கம்ப்ரஸர் இருக்கக்கூடிய வைண்டிங்குடைய டெம்பரேச்சர் வந்து it should be within 70 to 80 degrees centigrade. அதனால் நீங்கள் எப்பவுமே வந்து ஒரு சக்ஷன் ரிட்டர்ன் லைன் எவாபரேட்டர் the suction line and the temperature of the refrigerant should be within 20 to 25 degrees centigrade, the system life will be more. If this return temperature is more, 30-35 degrees centigrade,
extend my heartfelt welcome to our resource person, Dr. V.P. Chandramohan, Professor, Department of Mechanical Engineering, NIT Warangal, and I am happy to introduce him to the participants. Dr. V.P. Chandramohan holds BE in Mechanical Engineering, MBA in Project Management, ME in Thermal Engineering, and completed his PhD from Indian Institute of Technology, Delhi in 2007. He has approximately 23 years of research and teaching experience. He started his career as a lecturer in 2003 and joined NIT Warangal in 2013 and worked at various designations and currently serving as a professor in Mechanical Engineering Department at NIT Warangal. He has published 125 international SCI journals and 80 plus publications in various international and national conferences, book series and others. His work is also granted patent by the Indian Patent Office. He is an active reviewer in 40 plus journals. He is a rank holder in all spheres of his education. He has received DST Empowerment Scheme Award. He received more than 100 lakhs of grant for his research proposals. Because of his contribution to research, he is recognized as top 2% scientist in 2023 and 2024 listed by Stanford University. So we are happy to have such a dynamic personality among us today. We invite you, sir, to share your expertise with the gathering.
Good morning to all of you. So all of the faculty of our old institute or different institutes? Different institutes. Mechanical? All are mechanical, maybe other people also. EC. Okay. I expected more mechanical people. Okay, not easy. Anyway, then I will draft my talk accordingly because I need to cover up all the participants.
Few of them decide
Mechanical.
thermal background, specifically thermal background.
Okay.
They are very much interested to get more ideas about the TFT analysis. So it helps them to do further research.
Then we need to care about other participants
Yes,
also.
yes, sir.
So all are teaching professionals from institutions, no? Okay, good. Good to see you. Anybody from other states? All are Tamilians. AP. Kerala. So AP where, sir? Tamil you know, na? So Tamil kuda mukesirlo.
Yes, sir.
Okay, then we'll start then. Yeah, so I wanted to talk about the thermal systems, solar thermal systems. but I don't want to take all the solar thermal systems, whatever the people have developed. So whatever I have developed in my laboratory, so that 3 systems are explained here. So all the 3 systems are developed by our own team, and then we done number of numerical works, CFD simulations. So that's why this topic mainly for how the CFD tool can be used for solar thermal systems. Okay, so we worked for 3 systems. One is solar dryer, and then second one is solar updraft tower. Third one is solar vortex engine. That's the third one. At present we started the work, but still we started means 2-3 years before we started, and then we published 2 works. I will present those things also. So I think I will not go with much deeper because the audience from different streams. At least I will give some overall idea. So you will be aware on that, okay, by using this tool, we can solve such type of problems. Okay. So I will give you about the how the solar energy will be utilized for different countries for the past few years. You can see in 2024 there is a huge development in solar energy. There is a huge amount of solar plants that develop. Actually, writing is one of the communication tool. Do you believe? It's one of the communication method, writing. Through the writing, we are communicating others. Okay. Just like a film, number of directors are taking film. Whatever he is getting in his mind, that must be written properly in terms of screenplay, and then it must be shown in the screen. Okay. Whatever he will be felt, that everything must be reflected in the screen. While writing the screenplay, he will write whether that particular scene will create a comedy or emotion or whatever it is. That feel must be generated when a normal people see the film in the theatre, maybe in the home. That is the success of the director. Okay. So director படம் எடுக்கும் போது அவர் என்ன நினைச்சு எய்ம் பண்ணி படம் எடுக்கிறாரோ அது வந்து கண்டிப்பாக ஸ்க்ரீனில் வரணும். அந்த ஃபீல் வந்து அந்த ஆடியன்ஸுக்கு போய் சேரணும். சேர்ந்தாதான் அது அவரோட சக்ஸஸ். ஸோ அப்படி பண்ணும்போது தான் அந்த சக்ஸஸ் ரேட் வந்து அதிகமாகும். அப்படி பண்ணாத போது அந்த படம் வந்து சக்ஸஸ் ஆகாது. அது உங்களுக்கு தெரியும், எத்தனை படம் சக்ஸஸ் ஆகுது, எத்தனை படம் சக்ஸஸ் ஆகல தெரியும். who are the directors are top directors and then who are in the bottom list. Okay, so the top directors means they are successful directors. Whatever they are getting in their mind is perfectly communicated to the audiences through the screenplay and then screen. Okay, so such type of feel or such type of mentality must be needed for the authors first. Let us assume we are the authors. Okay, we are keeping something in our mind. We will be knowing perfectly this is the reason this is happening. Because of that reason the velocity is increasing. So that reason must be known to you and then it must be written properly with your own language. That is another important factor. With your own language. Don't copy, we should not copy from some other source. Okay, the journals are always expecting that they are expecting the individuality of the authors. Individuality of the others, not the individuality of other authors. Okay, if you are copying from other source, then we are copying the other individuality. Okay, so the journal editors are always expecting their own standard. So I am working in few journals, so I always expected the author's individuality. If after studying the paper I will be known whether it is copied or something is, or maybe it is AI tool written paper or something, I can easily identify on that. So as an editor I can take any decision accordingly. Okay, so your individuality is always important when it is coming as an author. Okay, so that's why the motto of this topic. Actually, I don't think so I can complete this topic within 2 or 3 hours, because I conducted this course for almost 10 universities, including NIT Warangal, and I conducted all the universities for minimum 3 days, maximum 5 days. So morning session and then evening session. Morning I will conduct the theory, and then afternoon I will give hand practice, and then immediately they have to write the content, and then I will correct lively to them, and then I will tell lively to them, this is the problem it has, this is the way it can be improved like that I will do. So such type of talk will help you. You can think about later if you need such type of help, but I also need time. It's not possible during the academic time, maybe in the vacation time it's possible. But anyway, I clubbed all my slides in a single slide. We'll see what much extent we can go here. Okay, one thing is, we are good others or not good others? Yes, we will say always we are good. Not only here, even if I ask the same thing in NIT or IIT system also, everyone says we are good, we are writing good. Even if I talk to the students, are we all of you good others? Then everyone say that yes sir, we are good others. But a evaluator can evaluate your writings. Okay, sometimes a reviewer or sometimes a editor can evaluate your writings, and then he can give the comments. He can identify whether it's a good writing or bad writing, and then he can identify. We can also identify now. We are identifying whether it's a good film or not good film. We are identifying whether it's a good story or not. We are identifying. We are giving some mark sometimes. We are telling others, okay, Mapla, you can see the film, like that we are selling. So like that, we are evaluating the film, like that whatever we are writing also must be evaluated by others, and then accordingly only the article will be promoted. Okay, so that we will see one by one. There are some important titles in the article. One is title of the article, second one is abstract, the third one is keywords. How we need to write all the three, we will see one by one. Okay, so we will start one by one. First one is, this should be error free, definitely it should be error free, and then this should be attractive. How attractive? By providing some colors. Yeah, actually whatever we have written in the manuscript, after studying the manuscript probably one will be knowing that okay, this is the content is explained in the manuscript. But the reader should get it based on your title. Based on your title, okay, based on the title, okay, this content only will be explained in the particular article. Like that he gets to the term. Based on the title itself. If you write a good title, then the Google search page, Google search engine, they will be searching the title, and then after seeing the title, a reader sometimes omit our title. In that case, the reader, as an author, we are not providing a good title. Okay, as an author, we need to reach all the readers. That's why title must be written according to the main article. What is the real content of the article, and that must be reflected in your title. This will create a comfortable feel to the reader. Or reader means an editor or reviewer or any learner, so that they can understand the work. Okay, comfortable feel means somebody assuming on that I need to write a very complex English language, very difficult English language. it should be 3 to 4 sentences will be clubbed and then written as single line. Like that we are feeling, we are assuming. Okay, like that, because I could be able to see some articles written like that. Some others are also assuming in that way. It is not at all necessary. Simple present tense is enough. And somebody assuming on that, we need to thoroughly know the entire English grammar. 100% grammar known, then only you can write a good article. It's not like that. Only within 5 to 10% grammar is enough for you to write a good article. Because most of the content we are writing in present tense and simple present tense and then simple past tense only. Okay, very rarely we are using some other tenses like future tense. Where we will write it? Scope, future scope only we will use future tense. Any other place shall we use past perfect continuous? Past perfect continuous had been used. Literature survey, totally we can write it simple past tense. Simple past tense is enough. No need. Experimental discussions you can write simple present tense. Simple present tense and simple past tense will occupy the 95 to 96% of the manuscript case. You no need to worry about other cases. Very rarely only you can use other tenses. Okay, you no need to worry about I don't know the grammar, I am very weak in English. So no need of that. Okay, so that's why they are telling. Yeah, if you write a simple sentence, simple present tense, everyone will get on that, no? I write, or I go to school. Simple lines. It will be comfortable to all. Okay, so English means
It's my immense pleasure to introduce today's resource person, Dr. S. Vijayan. He is at present working as a Chief Technology Officer for Shining Solar Technologies Private Limited, Coimbatore, and he is also acting as an Associate Professor in Department of Mechanical Engineering at Coimbatore Institute of Engineering Technology, Coimbatore. So he received his bachelor's and master's and PhD degree from Anna University in 2006, 2011 and 2018 respectively. Driven by deep passion for research, he pursued his postdoctoral studies in National Institute of Technology, Tiruchirappalli, specialization in solar thermal energy storage from December 2019 to May 2022. With over 15 years of combined experience in industry, academia and research, he has made significant contribution to the field of energy utilization and emission control. His research has been pivotal in advancing in technologies to improve the efficiency and reduce the environmental impact. As a co-principal investigator, he led a Department of Science and Technology India-funded research project titled Development of Solar Evaporative Tube Collectors with Inserted Baffles for Direct Air Heating in Industrial Application, with a total project cost of Rs 1.62 crores. Additionally, he has awarded said project under suit, securing a grant of Rs 23.76 lakhs for 3 years. He is authored more than 35 peer-reviewed international journal publications with 15 international and national conference papers and 10 book chapters for Springer Nature, CRC, Elsewhere, Intech Open and others, and contributing extensively to the body of knowledge in his field. His editorial contribution includes the book for Solar Thermal Conversion Technologies for Industrial Process Heating, published by CRC in the year of 2023, and book titled Efficient Energy Utilization and Emission Reduction Strategies in Plant Operation, also published from CRC in the year of 2025 February. His innovative work has been recognized with 5 granted patents comprising 2 international and 3 national patents. In addition to his research academic endeavors, he at present also serves as an associate editor for the Journal of Advanced Mechanical Sciences and reviewer for various reputed journals. At present, he also acts as a guest editor for Britannica Journal of Science and Technology, scheduled and published in the year of 2024. Further, he also acting as a co-founder and technical head for Shiny Unicorn Solar Technologies Private Limited for solar thermal application. So his research interest focused on solar thermal conversion system, thermal energy storage for low and medium temperature application and advanced heat transfer techniques. So with this note, I welcome Dr. S. Vijayan sir and introduce to our audience. Sir, this is the 6th day. So in the last 5 days, our audience go through the various concepts of solar thermal systems, solar PV systems, then some part of material science and nanotechnologies, and how to, if they have research, how to write it as a good research publication. All these things they understand. Then further they move on to an incubation visit at Kongu Technology Business Incubator. Then how to convert their research idea into a proof of concept prototype, and if it is viable, to make it as a viable product and launch it to the market. So with this overview, I introduce our audience to you. Sir, the session is yours. You may start your session.
Thank you for your nice introduction, sir. So first and foremost, I would like to express my sincere thanks to the management of JIT and the head of the department mechanical engineering and the coordinators for inviting me as a resource person for this wonderful faculty development program. So I would like to give a small note on this advancements in energy storage for industrial process heating applications. So before I begin, I would like to give a short note on this. So Sir has already delivered all those things. The book which we have published is of for the CRC press. So first one is focusing on the solar thermal applications for the industrial process heating, and the next one is for the efficient energy utilization and emission control. So both of these books have been published by CRC press. As Sir has mentioned, so I am working in Coimbatore Institute of Engineering and Technology, where we have an exclusive solar energy research center, so which has been called as solar energy research, where we have installed more than 15 different kind of solar thermal systems. Here you can see that. So the things are such as the solar thermal collectors, wire heaters, water heaters, dryers, and solar PV. So we have installed almost all kind of solar thermal application that includes even the solar cookers also. And for testing those thermal equipments, so we have developed here a solar indoor simulator, so which has been used for testing the solar thermal systems at indoor conditions without making we can have a control over the solar thermal simulation. And so with this output, we have gone for a DST funding, which we have received around 1.62 crores, out of which 99 lakhs have been granted by DST, and the remaining have been given by an industry. And where we have developed a solar air heater, solar industrial air heater, which utilizes the concept of inserted baffle plate for the evacuated tube. So where we have used different combinations of series and parallel connections. The series connection of the air heaters are being used to increase the temperature, and the parallel connections for the increasing or obtaining the required mass flow rates. So based on this, so we have installed that one solar collector in the leather drying industry, where we have faced the problem that the fluctuation of the temperature. So obviously it purely depends on the weather conditions. There we have faced the problem of the wide range of variations in the temperature. Because of that reason, they have faced a quality problem, which motivated me to go for why don't we incorporate a solar thermal energy storage system. So in order to stabilize the temperature output for the applications. So with that, gone for a postdoctoral fellowship research. There I have performed the thermal energy storage system design. So we'll get into today's presentation. So these are all topics that I am going to cover. The first one is of the global carbon dioxide emissions. So that's the greenhouse gas emission reduction process. Second thing is the introduction to the solar process heating and why do we want to go.
our department faculty members coordinating to make this event a success. So thank you.
Thank you, sir. Now may I request our Vice Principal, Dr. S. Ilangovan, to give the benediction address about the workshop. Sorry, FDP.
Good afternoon or good evening. We are in the verge of afternoon and evening. So it is actually a great pleasure to be a part of this Atal FDP. This 6 days information filled sessions, I hope that all the technical inputs what you have received from the experts, technical experts in the field of energy efficiency and energy managers, all those things would be really useful. And as we have opened up in the day one, so you would have received lot of research ideas. So this may be the starting point. This is not the end of the FDP. Now with the inputs whatever you have received, I hope that you will start your research or you will enhance your ongoing research what you are doing. And people who have already completed their PhD, I think you have to start the research in a different dimension, or you should increase the area of expertise of yours so that the will be really useful. So I congratulate the conveners and the Atal FDP coordinators of this particular session, Department of Mechanical Engineering, for the first of Atal FDP at Janssens. So it is, we are witnessing here that all the sessions were completely informative, and the enthusiasm what the faculty members, that the participants shown is really wonderful. We were witnessing that during the break session and other things. So I congratulate wholeheartedly the Department of Mechanical Engineering and especially the coordinators, Dr. Madheshwaran and Dr. Anoj Kumar, for their tireless effort. They have spent not only this 1 week, for the past 1 month I could say. From the date we have got the Atal FDP announced, means our thing got selected. From then they are putting in lot of efforts. So I request all the participants to give a big round of applause to the coordinators and the Department of Mechanical. So on behalf of the management, principal, and on my own behalf, I'm immensely pleased with the conduct of this particular FDP. So I hope this may be the starting point of these kind of FDPs, sponsored FDPs at the higher level in the future thing also. Thank you. Thanks for the opportunity. Thank you.
Thank you, sir. So, as a participant, I could also say that this created a platform for interdisciplinary research. We could understand how other platforms could be integrated with solar thermal, solar PV. So, as you rightly said, this is the really an enriching session for all the faculty who have been over here. Now, may I invite Dr. Vijayan, sorry sir. So, to deliver, to address the gathering. So, morning we had a very insightful session of solar storage systems. Probably we got more insights about that now. He will give an overall insight about this technology, about this FDP to the faculty. Sir, please.
Good evening to all present here. So here I would like to highlight few points that I missed to tell. That's of sustainability. Nowadays, the sustainability is a word. It seems to be like a buzzword. So everywhere you could find the word that's of sustainability. Even in your accreditation documents, there you would have seen the word sustainability. Even for the projects that we do. So everywhere the sustainability is being repeatedly used. The purpose or the reason behind that one is to have a lower, we have to reduce the impact on the environment. So that is the reason why we are being insisted to follow this sustainability. So being a mechanical engineers, we are in the position to inculcate, or we have the position to motivate our students to pursue a research or a project in the aspect of the sustainability. That means of the product, when they start to design a product, they have to make a consideration that the product consumes a lesser energy, and during the operation that takes up or that consumes less energy, even at the stage of disposal, that is having a very lower impact. For example, we are taking a plastics, so that consumes a higher energy in terms of an environmental impact, right? And when it is being disposed, it gets a lot of problems. So similarly, the material that we use for electrical thing, that's aluminum, copper, they are taking a much amount of greenhouse, that's impact factors when compared with the steel. So at the time of design itself, we have to take care of all those things. Just with the final thing, even in case if you replace a light, that's a normal tube light with an LED, or a normal fan with an PLDC, obviously we could save nearly 1,000 or 1,500 rupees bill per year. So the energy that we are saving is almost 2 to 3 times higher than the energy that we are producing it. So the sustainability that we need to take care. So we have to inculcate among our students community. Finally, I would like to express my sincere thanks to the management of Janssen's, the principal, vice principal, the head of the department, and the coordinators for giving me this opportunity. Thank you for the opportunity.
Thank you, sir. Thank you, sir. So definitely we will take up your words. We will educate our students to be more sustainable, to adapt sustainable practices, and as a good teacher, definitely this will happen. Thank you, sir. Thank you so much. Now, may I request our Vice Principal to honor our Chief Guest, Dr. Vijayan, with a small token of comment. Thank you, professors. Now I request the coordinators of this event, of this 6 days Atal FDP, to address or to give an insight or a consolidated report about this FDP.
So, good evening to all present here. So, we write this Atal FDP proposal for last 2 years. We applied the same concept for last 2 years for warning program, Atal online, then Atal offline. So every time we are submitting with a few minor changes. So when we are writing this proposal, our ultimate objective is how to integrate, how to conduct this program for multidisciplinary, not only for mechanical engineering. This solar, we hope, I guess, I am assuming that this solar thermal system, if it is integrated with other departments, definitely it should be useful for the community. So we always explain what is engineering to our first year students. So engineering is a thing which converts all the available useful resources into usable for enhancing the quality of the society or enhancing the comfortable life of the community. So we know that this solar thermal technology must be useful for the society. For that purpose, we are connecting all the departments together to make it more sustainable for our industries. So that is the objective. That's why we invite not only from mechanical engineering, we invite the people from material science, nano, business people, all are integrated as a part of this FDP program. So the FDP program started with Dr. T.V. Arjunan sir. So from his presentation, the audience understand that what is meant for solar heating, what are the different types of solar air heaters, water heaters, what is meant for ship system, that is to be understood in the first session. The second session will be taken by Dr. Saramana from NIT Trichy. He explained what is meant for solar PV, the basics of solar PV, what is meant for MPPT control, what is the maximum power point tracking. All these concepts will be explained by the professor. So in the second day started with Mr. Raghuram. He is the CEO for CARE Renewables Coimbatore. So he explained first thing, what is the importance of connectivity for developing the business. So if you want to do a business, even though you are technically feasible, economically viable, but the connections make your product to connect with the market. So connections are very, very important. Then he also addresses what are all the practical problems faced by Tamil Nadu Electricity Board, especially to adapt this PV systems. Then in the afternoon session, we go for Kongu Technology Business Incubator. We visit their Idipraya's laboratory, and Mr. Kannan, Technology Business Incubator Manager, he explained what is the difference between innovation and commercial ordinary business, what is the exact difference between entrepreneur, industrialist and the businessman, and he also explained what are the various schemes that is especially available for students, faculties and startups. So that concept will be very useful for the participants. So in the third day, the session started with my presentation. I explained why the solar thermal systems are not effectively implemented in the industries. One of the drawback is size. So if you want to reduce the size, you have to enhance the efficiency. If you want to enhance the efficiency of the system, you must be strong in your fundamentals. So if you want to do the analysis before go to the actual model, you must be very strong in the mathematical, theoretical analysis. So we described how to develop a basic analytical model. So in the afternoon session, Dr. K.K. Ajit Kumar from Matrix Innovation Solutions, he explains what is the role of magnesium in innovation development. So in the fourth day of the FDP, Dr. Murthy from Sri Ramakrishna College of Engineering, he gave a talk on small is different. Small is different. He explained what is the role of nanotechnology for sustainable and innovative product development. In the fourth day afternoon, Dr. Mohan Raj from Heat Pump Research Institute, he explained what is meant for heat pump. He also explained why heat pump is not exactly connected with the Indian market. So from his presentation, we understand that 90% of heat pump business people are not technical people. So that is the important observation. We observed that one. So and then he also explained how to select a refrigerator for our home, how to select the air conditioner for our home applications. Then in the fifth day, Dr. V.P. Chandramohan, Professor Mechanical Engineering from National Institute of Technology, Warangal, he explained what is meant for solar air heaters, solar dryers, then how computational techniques, especially CFD analysis, you use for analyzing the thermal systems. And in the afternoon session, he explained how to write a research article, then proposals and patents. So Dr. V.P. Chandramohan's presentation, and it is useful for us as a template. When you are writing a review article or research article, you may use this presentation as a template So if you use the template, we will not get confused which point to be described and which part of the manuscript. So that is very useful presentation for us. So today is the 6th day. So in the morning session, we started with the presentation of Dr. S. Vijayan. So sir explained what is the importance of energy storage, what are the major challenges faced by the industries and the research people, especially in energy storage and hydrogen production and storage. So with this, we also conducted hands-on trainings, especially in how to operate solar dryers and solar agitators, and we also described how to write problem statement Canva, value proposition Canva, and business model Canva. So these are all in the hands-on sessions. We covered these topics. So I hope what we planned that is to be executed. I hope it is to be useful for all of our participants. So the next important thing is the output and outcome of this FDP. So if you are a completed only in undergraduation, if you go for your research, definitely this FDP give various verticals that are available to do the research in this area. And we request our participants use this concept to prepare research articles and publish in well-reputed journals. So if you have enough publications, directly convert this as a proof of concept at the level of TRL level 3. So if you already developing a proof of concept, use our technology, use this FTP outcomes to convert your proof of concept into a prototype up to TRL level 6. If you already have a prototype, kindly go for the startup registration. So for that startup registration, at present we are running a small level incubation unit called Jansen's Create. It's a Section 8 company. So under this incubator, we have at present 2 schemes. We have one is MSME Hackathon 5.0. We are the host institute. If you have an innovative idea, kindly deposit your ideas under our institute. Then the second important scheme is Yukti Innovation Scheme. So if you have we invite you on, if you have an innovative idea, POC or prototype, kindly deposit your innovations in our program. Definitely we will recommend you in Yukti 3.0. At present, Yukti 2.0 nominations are already completed. So we are inviting you to submit your innovation in Yukti 3.0. So with this note, I thank Department of Mechanical Engineering and all the faculty members and the participants to supporting us to complete the FDP in a successful way. Thank you. Thank you.
So now I request Dr. L. Anuj Kumar. Before the vote of thanks, may I request any one or two participants to give an oral feedback about this FDP so that we could improvise ourselves. Any one or two participants can come forward to give an oral feedback.
Thank you for this opportunity. So first of all, I thank the whole management, all the coordinators for this wonderful program. So all the 6 days were really very excellent. So Atal FDP the winners of the Vagmo முடிஞ்சிச்சு. First day வந்தபோது பார்த்தீங்கன்னா the solar dryer பண்ண the food products bonus பார்த்தேன். So product வாங்கியிருக்கேன். It already related to my business sector. So already engaged in a company. So they are producing major products like the 350 plus products, mainly supplemented products. So these food products, according to that, used in supplements of supplementary. For example, health is more concerned in this era. To be frank, around 25 to 30 years itself, some people are getting heart attack or sugar problem, many kind of issues at the age of 50 or 60. But now they are attained at the age of 25 or 30. So these supplementary products will be helpful for many of the cases. All kinds of issues, it's having a solution, so that they have to insist here. So overall, the FDP is very fine, and really very thankful to the restaurant once again. dignitaries on the stage. The speakers are also very excellent. Even today, including Dr. James sir, all the speakers, really me and my colleague from Tamil Nadu College of Engineering, we really ரொம்ப ஷாக்கிங்காகவும் இருந்துச்சு. எப்படி இந்த அளவுக்கு எப்படி அரேஞ்ச் பண்ணாங்க, இது எந்த அளவுக்கு எப்படி அவங்க வந்து டெலிவரி பண்ணுறாங்க, ரொம்ப குவாலிட்டியாக இருக்குது அப்படிங்கிறது நாங்கள் பேசியிருக்கோம். ஸோ எவ்ரிதிங் இஸ் ரியலி எக்ஸலண்ட். ஸோ தேங்க்யூ சார்.
Thank you, sir. So, any of the other participants will come forward.
First of all, I would like to thank management of Jansen's Institute of Technology and the organizing team of this FDP. I'm really emotionally attached with FDP because we are as a farming community. I'm one from farming community. We are facing so many difficulties during the farming. So because of that reason, I left the farming. And then luckily I have joined with Madheshwaran sir. We are seeking so many different kind of sources, and then we moved something for new product development. Definitely people are speaking about sustainability. Without sustainability, so many businesses like farmings and all deeply affected. So this technology definitely will support those community. I'm very sure on that, because we are facing so many difficulties in collecting or making agriculture product into valuable one. So this one will be very helpful. Meanwhile, this one touched so many areas like how to developing the new ideas, and then how to converting this into prototype, and then prototype into business model, and then research paper writing. So many ideas are covered. Even though it is named as a faculty development program, it's not only a single objective. It touched, I think, all the key points. Thank you, sir. Once again, I would like to thank heartfelt thanks to management of Jansen's Institute of Technology and FDP coordinators. Thank you, sir. Thank you all.
Now I request the coordinator of this FDP, Dr. L. Anoj Kumar, to deliver the vote of thanks.
Good evening to one and all present here. So first of all, I like to thank the members on the dais and off the dais. So first foremost, I like to thank Atal FDP organization team and the AICT to providing funders, and they are directly providing the guide and support system how to conduct the FDP and what are the sources of required. So for the guidance, we are operating the FDP today. And firstmost, I want to thank our chief guest, Dr. James sir. So he is readily accept our invitation about that FDP we told. We nearly following from 6 months. We are not proposed that proposal within the day or within 1 week. So before 6 months, we have started to searching the resource persons who fit for this FDP title. So when you are seeing the title, so every resource persons are connect with the title to save the energy management systems. Okay, so including if you take Ajit Kumar, he is separate from other domain, but with the help of manganese, how to reduce the weight of each and every vehicle. So if you are going to reduce the weight of the vehicle, it is also directly connected with how to save the energy. So nearly we are selected persons like that, and we are forming the entire team. So resource persons and coordinators and the faculty members. Okay, so if you are going to conduct this kind of FDP, so there is the guidance between minimum 30 participants and the maximum 50 participants allowed to attend this FDP. So we are always disturbing our faculty members to get the participants here. So I know thoroughly from Alexander sir, 2 other participants are here. From our HOD sir, already deputed 3 participants. From myself, Madheshwaran sir, and other faculty members in our department. So So they are entirely, tirelessly they are working and collect up to we are achieving 49 faculties. So totally the 40 students, we reached 49. So we have missed our 2 internal participants. So that is the percentage. We are only provide 5 participants from our institution. That is top maximum we have provided 7. So at last time other 2 participants not able to come here. Others we reached above that limit. So I thank that provide that opportunity, okay, for our HOD. So he is the key model to bring that this kind of participants here. He already daily he is instructed to our faculty members. Sir, we need 3 faculty. So from your side you need to go. So what happens, sir? We are making Excel sheet. Daily we are making Excel sheet. In that Excel sheet we are daily checking which faculty connect with other faculty members. So daily we are insisting. So next I like to thank our HOD. Thank you, sir. Next I want to thank our vice principal, sir. He is always a busy member. So he is not a vice principal here. He is also a placement coordinator. Previously he is the HOD of AA department. So previously he is a HOD of PB department. Sir is having a more number of positions here. So whenever we are calling, sir, this is we are making that program. We need to connect with us. This is the inaugural function, sir. We are not providing that statement not before 1 week. So within the night we are calling means sir accept and come here. So sir is a very known person here. Sir, thank you, sir. Nice to meet you, sir. Sir. And next to foremost, I thank our coordinator Mahesh sir. He is what is very tremendous. Okay, so he is not tired. So we are both are working together. So sometimes I get vexed, but he also gives the energy to me, sir. Okay, no issue. We can do like that. Whenever we are going to work with the state of organization, we need to meet with more number of people, not even coordinators and other persons conduct this kind of activity. Up to we want to go to office bearers, non-teaching member supports, and the speaker supports, and the technical team. Okay, these kind of persons we need to meet, and daily we need to insist. So if you see this chat arrangements, we are followed 4 days to bring this arrangement. Daily we need to connect with non-teaching faculty members, speakers, sir, what happened to that arrangement for everything. So at the time, sir gives that motivation to me, and we can arrange this kind of 2 TVs, camera, everything. So thank you, sir. So next to foremost, finally my appreciation and sincere thanks to you. So nowadays we know very well about how the colleges are running on. Okay, so without on duty, right? So without CL, okay. So you are come and attend that FDP's 6 days. It's really really what I could say, no words. Okay. So admission work is there. So 14/7 is the college reopening for all the faculty members. We need to prepare the class work, and we need to engage with the students who are absent last 7 days. We need to call them and bring the students to college, and some of them have exams. Okay, they need to do is the result analysis file. So we know that difficulties to attend this kind of offline FDP. Okay, it is really painful. We know that. So sincerely thanks and heartfelt thanks to entire participants. Thank you, sir. And finally, I thank that our faculty members, mechanical team members, and non-teaching faculties, and technical supporting team, Rajkumar sir, everyone to complete the 6 days FDP successfully. Thank you, one and all.